Okay, now let's talk about the length of an arc. Now, what I mean by the length of an arc would be if we look at a circle and we had an angle that opened up, we'll call that theta. The length of the arc would be this in red here. Now, what you can do is you can imagine if you cut the circle, if this was a string that you could cut, and you cut the circle here and here, and you laid out this length in a line and you measured it, that would be the arc length. So it could be in feet, it could be in inches, it could be in centimeters. This is going to be some kind of length or distance. The formula for finding the length of an arc is right here. S is your length. So that's going to be in the same units as R, which is your radius. So if your radius is in inches, then your answer is going to be in inches, the length of your arc. If your radius is in feet, then your S, the length of your arc, is going to be in feet. Okay? And then theta is your angle. Now, the thing with this formula, though, is that you have to have your angle in radians for this formula to work. So if your angle is given in degrees, you need to convert it to radians before you plug it into your formula. So to find your arc length, you would take the length of your radius and multiply it by your angle in radians. So the first example says, find the length S of the circular arc. If your radius is 2 and your degrees of your angle is 102. So we have an angle. The radius is 2. So that's going to be 2. Now it doesn't tell us units here, so this is going to be unitless. And then it opens up 102 degrees. So if I open up halfway around the circle, that would be 108 degrees. And if I open up a quarter of the circle, that would be 90 degrees. So a little bit past 90 degrees, we're going to open up. So we're going to start here, and we're going to open up somewhere in here. That would be 102 degrees. So what we're looking for is the length of this arc. That's the blue part. If this was a string that I could cut and lay out, how long would that be? So we're going to use the formula. S equals radius times your angle. But your angle has to be in radians. So I'm going to take 102 degrees and multiply it by pi over 180 degrees. And that way I can get rid of my degrees and cross them off and be left with just radians. So if I take 102 and divide by 180, and then I reduce that, I'm going to get 17 over 30 pi. So this is my exact answer. And unless the problem tells me otherwise, you want to keep it as exact until the very end. Okay, so now we have our angle in radians. So I'm going to take my radius, the length of my radius, which is 2, and multiply it by my angle in radians. Now my angle in radians we found was 17 pi over 30. So my final answer is going to be 17 pi over 15. So that would be my exact answer. Now if I want an approximate answer, I would take 17 divided by 15 and use the pi button on my calculator, multiply by pi. And if I round it to, say, 2 places, I would get 3.56. Now, if the problem told us that the radius was in inches or feet or something like that, we would have to make sure to include the units in our final answer. The second example says, an arc length of 120 feet subtends a central angle, theta, in a circle that has a radius of 30 feet. Find the measure of the angle in degrees. So in this problem, they're asking us to find the angle, and they're giving us the length and the radius. So it tells us that the arc length is 120 feet. So I'm going to put that in for S. It says the radius is in 30 feet. So I'm going to put that in for 30, and that's times theta. Now, if the radius was given in inches and the arc length was given in feet, you would have to make sure that you change it so it's all in feet or all in inches, or this won't work. So you want to make sure that the units that you're using are consistent. So now to find theta, my angle in radians, I'm going to take and divide both sides by 30. So when I do that, I get 4. And remember, when you're using this formula, this is in radians. The question asks us to then give us the answer in degrees. See, it says up here, give the answer in degrees. So I want to take 4 radians and change that to degrees. Now, if I want degrees, I need to make sure the 180 is on top and the pi is in the bottom. So that way I can cancel my radians versus canceling degrees. So I'm going to take 4 times 180, and that's going to give me 720. And then on the bottom I have 1 times pi, which is pi, and this is in degrees. This would be my exact answer. If I want to put it in a decimal approximation, I would have to take 720 degrees and divide by pi. And that would give me approximately 229, if we round it to 2 places, 229.18 degrees. So this would be our approximate decimal value.